Okay, we've learned a lot about habitat management and different habitat components. Today we're going to take a look at the aquatic environment, habitats associated with them, and how we then apply that to manage fisheries populations and different techniques used for fisheries. So, to start off with, it's important that we look at different habitat types and know the terminology associated with each type. The first is the saltwater system. We don't have any of these in Colorado, of course. You may hear them referred to as marine systems or saline systems. And then down here we have limnology, or the study of freshwater systems. So we'll focus today on our freshwater systems. Within the freshwater systems, we have two environments, lotic environments and lentic environments. Lotic environments are our river systems. Lentic environments are our still water systems, which can be a variety of different habitat types, from ponds and large lakes to almost small little puddles that may even be ephemeral and not around all year. Okay, let's take a deeper look into the lotic or riverine environment, as your book refers to it. The first thing that's important with this system is that there's a unidirectional flow. Water has an upstream and a downstream direction. It's under continuous physical change, and we're going to spend a little bit of time looking at that change here today. There's a high degree of both spatial and temporal heterogeneity. So spatial is referring to like across the landscape or across the river, and temporal is how it changes over time. Hetero meaning different, and heterogeneity then meaning differences within the system. Okay, in lotic environments, variability is very high, both within each system and over time. And the biota is specialized to live with flow conditions. And then the lentic or lacustrine environment is consisting of standing water. There is some vertical stratification up and down within the system. We'll look at that today. There is horizontal stratification across the lake or the pond. And then we have another little category that I threw in here, and we'll call it the transitional ecosystem or palustrine ecosystem. This is your wetlands, bogs, marshes, where there may be standing water, but there may not be standing water. They are characterized by having hydric plants, hydric soils, and hydric plants and hydric soils, meaning the soils and the plants are influenced by water at least at some point during the year. And I should say standing water or saturated soils. Everything obviously is influenced by water, vegetation-wise, but in these systems, it plays a stronger role. Okay, so then we also could categorize our water systems or aquatic systems by temperature. And we do this more so when we're speaking of habitat types for fish. So we have our warm water systems. Those are usually systems all the biota in these systems can tolerate temperatures above 80 degrees. So, they can handle some pretty warm water. They're also defined as those water-supporting fish other than salmonids. Salmonids are everything in our trout family and salmon family. So warm water systems holds probably the most diversity of our fish species. So what do these systems look like? What do you suppose would be a characteristic of water that can heat to 80 degrees? Well, it's important to maybe just step back and think about how would that water get warm. And for the most part, that would have to do with the sun and the radiant energy coming from the sun. So we have water that is still for long enough that the sun can heat it, or water that is shallow enough that it can thoroughly heat and warm up. And our cold water systems, they have a maximum temperature of 50 to 65 degrees, but oftentimes are hunkering down there around the 40-degree mark. And our trout and our salmon are our cold water species. These systems then, what would they look like? They're going to look more like typically flowing waters or deeper waters within lakes, areas that are not as influenced by the energy from the sun. We also have a third category called cool water. These are kind of our in-betweeners. So some species like walleye, striped bass, they need temperatures on the upper end of the cold water and lower end of the warm water systems. And I should mention that for warm water systems, some fish species in there would be like your bass, your sunfish, perch, kind of some of your larger bodied fish. Okay, so looking at a lotic or a riverine environment, let's think about what are the drivers that influence that in-stream habitat. Well, the water in any water body is highly dependent upon the watershed, and it's important to know what a watershed is. A watershed is just an area of land that then drains water both above ground and below ground to some kind of common water body. So it's just the area of land that drains water. The watershed itself is land. It's not a body of water, but it's all flowing toward a body of water, usually for which it's named. So you'll hear the Poudre River watershed or the Mississippi River watershed. And you can have smaller and smaller sub-watersheds within a larger watershed. But I like this graphic. You can imagine a raindrop hitting the hill and flowing down into some of these lakes and ponds. So you can have it flow into a river, or you can have it flow into a lake, and all the water that drains to that common point is part of the same watershed. Okay, well, what's going to characterize your watershed? The terrain, both steepness and the roughness of the terrain, the size of the watershed, and like I said, every water body is part of a watershed, and some of them are part of the same watershed on a larger level. The land use around those watersheds. So if you have land uses that might influence water quality, both in the groundwater or surface water, whatever's happening in that watershed will impact the body of water that it's draining to. And maybe disturbances. And that kind of goes right along with land uses, but when you have a large disturbance, that can impact what is running off of that watershed and into a water body. This is a map of several smaller, each color here is smaller watersheds, all part of the Poudre River watershed, which is running through the main part of your picture here. And what this is a map developed after the Hyde Park fire, looking at priority areas regarding how they might be damaging to the Poudre River watershed. So, or to the Poudre River, which is drinking water for City of Fort Collins. So the areas in red here, after the fire, had higher amount of damage to the soil and vegetation, which could increase the amount of sedimentation entering the Poudre River and therefore the water quality for Fort Collins. So we have different ways of prioritizing these sub-watersheds, and that's for another day's lesson. Okay, let's look at the lotic habitat for a minute. We'll just look at the different habitat types here within a river system. So, what influences stream habitat or watershed characteristics we just covered, and then the riparian zone characteristics. So a riparian area, which I've mentioned in class numerous times, but it is simply the transition between the aquatic environment and the upland environment. So I like this diagram here. You can see we have our aquatic zone down here in the bowl, and then we have this vegetation that is all in part influenced by this aquatic zone. And maybe that is influenced just because the groundwater is at a higher level and these plants may depend on it. It might be influenced because of how often or likely the area is to flood, and you can see that this whole flood prone elevation does go through most of the riparian zone. And beyond that, you're going to get vegetation that is less influenced by the river system, and that would be called your upland. So when we're thinking about what is going to influence the river itself, the vegetation types within that riparian zone can definitely influence it. They're going to maybe help stabilize the banks, they're going to be dropping leaves and inputs into the water, like litter, and we have aquatic invertebrates in the water that will help break that down. It'll add nutrients to the water. There may be soil inputs into the water, and when soil gets into water, we now call it sediment. But the steepness of the banks, the vegetation on the banks, can influence how much soil then enters the aquatic zone. And then the biotic communities, both in the riparian zone and in the aquatic system, will interact with each other. And so you can say that those terrestrial inputs, maybe it's a spider climbing up this piece of grass that falls off and can get gobbled up by a fish. And so we have inputs of biotic things falling in or entering in some capacity into the aquatic system. The water table. This can influence the river because if the water table is high enough, it may be feeding that stream. If the water table is low enough, then the river may be losing water to the groundwater. Okay, but as we're looking at fish, we have 5 characteristics that are super important. The first is water quality, and I'm not going to get into a lot of detail about what affects water quality. We'll come back to that in a little bit, but won't cover it in detail. Your book does do a nice job of covering it. Food sources. Fish want to eat just like everybody else, so that's really important to fish. Biotic interactions, both with aquatic and other aquatic organisms and terrestrial organisms. And then I want to focus for a minute on this point, the stream flow. The stream flow is very important to fish, not just because fish need water, and if the stream's not flowing, then where do they live? Obviously, that's important. But it determines and drives so much about what's happening in the system. And what goes right along with that is the physical habitat that is developed in part because of that stream flow and some other influences there. Okay, so our stream flow influences the water quality. It influences the food sources available, the biotic interactions, and the creation and availability of physical habitat. Basically, the other 4 things here on this slide. So we really need to understand stream flow because they play such a strong role in everything that fish need. So, as we dive into it, we need to set our brains thinking about energy again. So much of these systems, this ecosystems, and the way they function all revolves around energy, whether that's energy as heat, or in this case, it's energy more as power, as we would think of it. So, streams are trying to dissipate energy or trying to reach an equilibrium. So as streams move from your headwaters to the lower elevations, they gain energy. And all of you have witnessed this, right? You're up high in a little mountain creek trickling down the mountainside, and you follow that down to a major river. As that water goes down, it builds in power, it builds in energy. And you have to somehow get rid or dissipate that energy. So the rivers dissipate energy in a variety of ways. One would be just by contact with vegetation. That might be logs in the river. It might be rooted vegetation along the banks. It might be roots from trees in the banks. When the water hits that vegetation, it will dissipate some energy and slow. Turbulence. Turbulence is a good way of dissipating energy as water flows over rocks. Those rapids that we like to go on when we're rafting create turbulence and dissipate energy. Erosion is another way of dissipating energy. As the river picks up part of the stream bank and erodes it, it's dissipating energy. The roughness of the channel bed and the bank. If the water is having to flow over large rocks on the bed of the river, it will dissipate energy that way. And then the last reason, which we'll spend more time here talking about, is transporting sediment and other debris within the river. So all of these are ways that the river is going to get rid of energy. And now we'll talk about why that's important in the next presentation. And we will start with this important point that stream form influences stream function.